So what we've learned so far is how to build a fraction. We did that with our names, yeah? And how to simplify a fraction. So we're going to combine these two skills that we've just learned now, and we're going to combine them by answering an exam-style question. Okay? And this is it. This is it. It's a non-calculated question. Shannon works in the mobile phone shop. This week Shannon makes 19 pay-as-you-go phone sales, 57 SIM card with handset contract sales. The remaining sales were SIM card only contracts. Shannon made a total of 144 sales this week. What fraction of the sales made by Shannon this week were SIM card only contracts? Write your fraction in its simplest form. So what it's asking you for there, it's asking you to first of all to build a fraction regarding the sales that she's made. Then it's going to ask you to simplify those fractions. Now okay, the bottom number's easy to spot. What's the bottom number? 140. Yeah, 140. Because that's the total. Yeah? So, that's great. What we need to look at now is the wording of the question, because we've got some other numbers. We've got two numbers here, 19 and 57. 19 of those were pay-as-you-go phone sales. 57 was SIM card with handset contract sales. But the question says the remaining sales were SIM card only contracts. So SIM card only, not with the handset. What fraction of the sales made by Shannon were SIM card only contracts? So what you've got to do now is find the difference between that number and those two numbers added together. Because they're your pay-as-you-go phone sales, they're your SIM card sales with handset. Remaining sales were SIM card only. So we need to find out how many sales were SIM card only. So we've already got our bottom number for the fraction. That's okay, we're halfway there. Next thing is, out of all those sales that she made, of three different types of sales, how many of those were SIM card only? So out of the 114 sales, take away the 19 that were phone sales, take away the 57 that were handset sales, and whatever you've got left are the SIM card only contract sales. Does that make sense?
Yeah, could you add 57 and 19 and then take that away?
Of course you can. Of course you can. Yeah, and that's the way I would do it. It's the easiest way of doing it. Yeah. So let's do that. Let's add 19 and 57 together. I'm going to do it the old-fashioned way. $76. Yeah, we all agree. 76. So 76 of those sales were made up of those two. The rest of the sales, the remaining sales, were SIM card only contracts, and that's the number that we need. So we've got to do a little bit of subtraction now. So now we've got to do 114 minus the 76. Because she made 114 sales, remember. 76 of them are these two. And the remainder, so whatever's left, is the number we're looking for here. Okay? So what we've got left, if we've got 114 and we're going to take 76 away, what we're going to have left?
38.
38? Do we all agree?
Yeah.
So when we say this back to ourselves, hey Shannon, how have you done in the shop today? I've done pretty good, I've done 114 sales. Shannon, how many of those were SIM card only contracts? 38 out of 114 were SIM card only contracts. We've built our fraction. Halfway there. Now we've just got to simplify that fraction. Now your times table probably doesn't go to 114 in that particular column. So let's see if we can simplify it. Can we make 38 over 114 simpler? I've made a typing error. simplify it. I'm going to have a go on here. because there's a typo. Oh, it's non-calculator, innit? Ba-ba-da-bum. Oh, hang on. I think that's right. I think we've got the right answer.
Oh, I put it down there.
Look at you did that really quick.
Really got the top answer.
Yeah, I divided it by
Did you
two.
get,
I've
did
got
you
that.
get it to
Right,
19 over
Easily.
57?
Yeah, I've done that.
Yeah, and then that's the tricky bit,
I
isn't
didn't
it?
think it
That?
was simplified.
No,
anymore.
I
That's the tricky bit, that. I didn't think it'd simplify anymore. I doubted myself for a second there, to be perfectly honest. Thinking to myself 19 and 57. But how did I kind of recognise that? How did I recognise that maybe I could make that 19? How I could do it? Well, I thought about the 9. And I thought, well, 3 9s are 27. That's what I thought about originally. 3 9s are 27. So I knew I could get that number ending in a 7 at some point. So I thought to myself, I've got 19 3 times. That's going to be 27 plus the 3 10s, 57. Yeah? So that's how I kind of worked that one out. That's how I worked that one out without the calculator. So the answer should be a 3rd. The answer's coming up on the screen is the correct answer. There's just a typo in it, to be honest. There it is. That says 144. It should say 114. So 19 over 57, divided it by 2 to start with, and then divided it by 19. If you're not so sure, do your 19 times table. 19 plus 19, 38, plus another 19, 57. There it is, yeah? So it's a bit easier to add your numbers up sometimes, just to help you along. Yeah, just to help you along. Because when you first look at that, you think to yourself, well, I can't divide it by 2, can't divide it by 3, can't divide it by 4 or 5, so it starts to look a bit confusing. And I think that's why they're designed like this sometimes, because to make you think, that's impossible. It's impossible, because the 2's won't go into it. I can't half it, I can't do this, I can't do that, I can't even half 57. So it's a case of then thinking to yourself, alright, I've exhausted the other option, I've exhausted that option now. I'll tell you what, let me try dividing the top number by the bottom number. Yeah, so it's asking you to use a couple of the skills that we've already learned. Does that make sense? Yeah, does that make sense? So,
Do you know if you got 1957?
Yes.
As you said, that wasn't a exam question. Would you lose all the marks?
no,
for that
you'd still
because-
get a mark for that, you've just not got as simplified it as you'd get the mark for this bit. You'd probably get 2 marks for that, to be honest, because you've done an addition and a subtraction, and you've got yourself the fraction. You would probably just lose a mark for not getting as small as you possibly can. But again, it's going back to what we looked at earlier on, where when you see what you've got, then you've got to decide what you're going to do with it. And we decided that, yes, sometimes you need to do a combination of things to get the right answer. It's like this one, we had to do an addition, then we had to do a subtraction before we even got the fraction. Yeah, my first thing is going to be, I'm going to start by dividing by 2, but once I've divided by 2, I've come to this sticky situation where I'm not recognising the numbers. So then you think to yourself, okay, what's the next step? Well, the next step is divide the top number by itself. 19 divided by 19 is going to give me 1. So what about 57 divided by 19? Do me 19 times table. Oh, there it is. It goes in 3 times. Boom, you've got your bottom number. So all these things, they're not going to jump out at you. They're not going to be easy for you to do. They're going to require you to use a combination of different recognising skills. And what I say is once you've got your first part of the sum, just stop a second, look at it and think to yourself, right, what actually have I got? I've got two even numbers, so I know I can half them. Boom. Once you've got that, you've got another number. That number's forgotten about then, it's gone. Think about something different. What have I got now? I've got 19 over 57. Ooh, they're tricky numbers. Right, okay, so dividing them by 2 is not going to work. What's my alternative? Try dividing the top number by the top number. That's definitely going to give me 1. But can I get 19 up to 57? Because that's the next bit, because I'm going to divide 57 by 19. Yeah, you could do it with a division, of course you could. Or you could just write your 19 times table down, and then suddenly, there it is. Boom, 3. Yeah? So that's the way you've got to approach these kind of questions. You've got to look at each individual question, sum that you get, maybe with a fresh set of eyes. Okay? And think there might be a different way of doing it. Okay? Makes sense? So that's kind of the style of question you might get in the non-calculator paper. That. I think that question actually was worth 4 marks in the exam. Because there's a lot involved in it. But yeah, it's this kind of style of question you could end up with. Alright? Kind of style. So make sure you read the question carefully. Make sure you pick out the information that you know. Okay? And the clues are in the question a lot of the time. Total of 114. You know that's the bottom number, because what's the bottom number of a fraction? It's the total. Yeah? It's just that bit there that's the tricky bit, and then making sure you link this bit with that bit there. What do you say? Does it make sense? Yeah, does it make sense? So far so good. Are we enjoying fractions?
Silence.
Silence. I'm used to that. With fractions anyway. So, let's start to mix things up a bit now. Let's make it a bit more tricky. Okay, let's make it a bit more tricky. We're going to start to look at some improper fractions and some mixed numbers. Sorry, yeah, some improper fractions and some mixed numbers. Okay. First of all, let's identify what they are. What's an improper fraction and what's a mixed number? So I'll use 2 different coloured pens. I'm going to try and find a black pen that actually works. Somebody's used all these while I was off last week. Okay. Have to change the bandage a bit all. So that's as improper. Okay, let's draw a line here. You leave your stuff. Oh, there you go. That's better. So that's an improper fraction. We're going to do an improper fraction there, and we're going to do a mixed number here. So, what's an improper fraction? An improper fraction is when the top of the fraction is bigger than the bottom of the fraction. For example, 11 over 4. Okay? That's an improper fraction. A mixed number is where you've got a great big number, a whole number, for example the number 3, next door to a fraction. Okay? So we've got an improper fraction. It's improper because the top is bigger than the bottom. And we've got a mixed number. That's a mixed number. It's a mixture of a whole number and a fraction. Okay? What we need to be able to do, what we need to learn how to do, is how to change one to the other. Okay? Because in your functional skills, in your maths exam, you may get a question where you've got that number, you've got to add it or subtract it to this number. And at the moment that's impossible to do, because just look at them. Every number's different. So we have to learn to be able to change between this to this, change between that to that. Okay? And that's that's the skill we've got to learn to do. How can we relate this to real life? Well, let's think about this. Let's think about this. In this particular instance here, I'm just going to get my blocks out. I'm just going to get my little blocks out. So let's just imagine I've been to the, I'll use pizza as an example. No, I'll use a chocolate bar instead, sorry. I'll use a chocolate bar rather than a pizza. I'll use a pizza for the second. So I've got a chocolate bar there and I've opened it up, a Galaxy, and there were originally 12 pieces, but I've eaten one while I was waiting for you to come to class. So what I've now got left is 2, 4, 6, 7, 8, 9, 10, 11. So what I've got left, I've got 11 pieces of Galaxy left. There it is, because I did have 12 on the bar, but I've eaten a piece, so I was waiting to come to maths. So there's 12, there's 11 little squares of Galaxy chocolate left. So I've decided, Shelley's come to class and she said, oh, a big peck, have you got any chocolate? I said, yeah, I've got some chocolate. Well, I could just eat like 4 pieces. So I said, okay. And Samantha comes to class and says, I could have like 4 pieces of chocolate as well. So I think, right, okay, I've got a Galaxy, I'll give you 4 pieces each. Yeah? So I give 4 pieces to Shelley, and I give 4 pieces to Samantha. That leaves me with 3 pieces left. So what I've basically done there, I've divided that 11 by 4. And it's given me the answer of 2 with 3 pieces left. So what I've done, you see, I've managed to give me chocolate to 2 people, because they've both got 4 pieces each, and I've got 3 pieces of the chocolate left. Okay. If I'd have had another piece, I'd have had 4 I'd have had, would have been as 3 people would have been out of the chocolate. So basically all I've done there, I've took that 11 and I've divided it by the bottom number. Because what's that? What's that? It's a divide line. 11 divided by 4. How many 4s go into 11? 2, 4, 8. How many left over? 3. 1, 2, 3. That's where that number's now come from. Okay, does that make sense? Yeah? It makes sense. So we've converted an improper fraction into a mixed number. Quite simply, all you do, you divide the top number by the bottom number. You see how many times the bottom number goes into the top, that produces this, the whole number, and whatever your remainder is, goes over the original bottom number. Remember what I said at the beginning, the bottom number of the fraction is the most important number. Okay? So that's how that particular one works. So far so good. So how do we get then, because we've got a mixed number now, so how do we get from a mixed number to an improper fraction? Okay, how do we change this to an improper fraction? Okay. For this, there's a little acronym that I want you to use. And I want you to get mad. Okay? I need you to get mad with mixed numbers. What does that mean? Okay, well, I'll talk you through it. The M stands for multiply. Okay? Multiply. You multiply the whole number by the bottom of the fraction. 3 times 7 is 21. Yeah? 3 7s are 21. I'll do the A in a different colour. The A stands for add. You then add the top number of the fraction. 21 plus 1 equals 22. You then put the whole answer over the D. The D stands for denominator. So you put the full answer then over the denominator, which in this case happens to be a 7. And that's how you work that one out. You get mad. Okay? So we've converted a mixed to an improper fraction. Okay? A mixed number to an improper fraction.
Okay.
Nice and easy, isn't it? Nice and easy. So let's think to ourselves, okay, we've gone to the pizza place, we've gone to Domino's Pizza, not many pizzas get cut into 7 pieces, but it doesn't matter. So we've gone to Domino's Pizza. And we've bought 4 full pizzas and we've had them cut into 7 slices. I don't know why they've cut them into 7, but they have. But we've got 4 full pizzas, each one cut into 7 slices. We're driving home in the car, it's quite a long journey, we get stuck at some traffic lights, so we decide to eat some pizza and we eat 6 slices. So now what we've got in the car, we've got 3 full pizzas and 1 piece of the 7. That's what we've got left in the car. So when we get to the house to where there's a little party going on, we take the pizzas and we say, got some pizzas. How many slices of pizza have we got? Somebody says, how many slices have we got, Pete? Well, I ordered 4 pizzas, each one had 7 slices in. But I've eaten 6 slices of pizza. So we open the box up and we count the slices. We've got 3 full pizzas, so that's 21 slices, and then just 1 slice on its own. 22. We've got 22 slices of pizza. Yeah? That's how it works. That's how it works. But you just remember that little acronym there, MAD. Multiply the whole number by the bottom of the fraction. Add the top number of the fraction, which gives you that. And then D, put the whole answer over the bottom number, the denominator. Because that's the important number. It doesn't change. Well, not yet anyway. Okay, there we go. So that's how to go from an improper to a mixed, and how to go from a mixed to an improper. Feel good about that? Good stuff. Let's see, there's a couple for you to try on here. No, not just yet. Okay, well there's some for you to practice in your book. So, what we've got next. Mixed numbers. 1, 2, 3, 4, 5, 6. Converting the mixed numbers into fractions. That's this method. And then over the page, converting improper fractions, or not over the page, maybe at the bottom of your page like mine are here, converting improper fractions to mixed numbers. So your first 6 are this method, your second 6 are this method. Okay, have a go at those, let's see how we get on. Again, if you need to, use your times table, need your calculator, use your calculator. I'd rather you got used to the skill rather than worry too much about number skills. So these are mixed numbers into fractions, that's that bottom method.
Yeah.
And then the other 6, these fractions into mixed. Oh, you've only got 4.
Yeah, we've got
Yeah.
4 and a half.
Yeah.
Six.
I was looking and I'm like, where's the rest?
Right.